So Google just launched the best AI image generator model out there, which goes by the name of Nano Banana, or at least that's what people call it, since its real name is actually Gemini 2.5 Flash Image. So we decided why not put it in good use and combine it with other cool models and tools to create a whole N8N workflow out of it, which leads us to this workflow, as you may have heard or read in the title of the video, which is a UGC-style ad video creator using N8N. This workflow is actually part of a bigger system that we are creating, which generates unlimited creatives for e-commerce brands and e-commerce businesses, starting with a UGC-style ads, but we are going to iterate throughout the next videos, implementing things like generating a product pack from photography to generating cool description and images and ad copies, generating static ads, etc. So this is the first part that we are started with. I've seen a couple of videos that have already gone through doing UGC-style videos using N8N, but in this video, what makes it special is we decided to make it a low cost as much as possible. That's why we combined some cool open source models and tools to allow us to create the output or the objective of this video, which is generating UGC-style videos. This workflow and the next workflows or the iterations of it are going to be available in our membership, which is $20 a month. If you want to get it, you can visit the link in the description, in which you will get access to the previous workflows that we have created on this channel, as well as the next workflows that we are going to do, starting with the iterations of this system and including multiple other workflows or ideas that we have in mind already. If you don't want to pay the membership for $20 a month, you can go to the shop as well and get the JSON template on its own for $8. You can find in the shop some previous workflows that we have done, as well as this new one that's gonna be included soon as this video gets uploaded in the shop, and the next iterations of it as well, so you can buy it separately. Or you can save up money and get the subscription, $20 a month, a whole list of workflows that are available. If you don't want to pay any money, of course, you can still be a member of our free community, in which we share the assets, things like the prompts, the HTTP request bodies, etc., and the code node content. And of course, you can follow the video in a do-it-yourself method, of course, following the video and implementing the assets to copy and paste, and you will create the workflow on your own. So yeah, let's dive deeper into our workflow now, and let's start by breaking it down. Let's talk a bit about the requirements and the things that are used inside this workflow to make it functional. So we have used a couple of paid features and paid tools, as well as some open source tools and models. Starting with Fal AI, which is an AI model aggregator. That way you don't have to go in and learn multiple ways on how to connect different models. You will have it here. It will provide you a universal way of connecting with different APIs for different models at a cheap cost, of course. It works with a pay-to-go model, so you'll have to deposit money in your account and then use it in the model you wish. Every model has its different cost and billing, of course, so you will find it in the model page. So if you go here and find the banana, for example, we go here, it will give the cost for per image. So this one costs $0.039 per image, and it will cost $1 if you run the model 25 times. So this is the first one that we're gonna use for the image generator model, Nano Banana. For the video generator model that we use in the video, I will get to it later, as well as for a lip syncing model that we'll use at the end of the video. One more thing we have used is the NCA Toolkit, which was made by the YouTuber Stephen G. Poe. He created this whole NCA Toolkit, which replaces multiple APIs, and it's free. You can self-host it and deploy it on your local machine. We have used, of course, N8N self-hosted and MinIO for this. And the last thing we have used, which is our voiceover model, which is Kokoro TTS. We have previously made videos on how to implement and use Kokoro on your local machine, as well as how to deploy N8N and self-hosted on your local machine, and how to use the NCA Toolkit with MinIO, which is the local storage that we'll use for the video and for the NCA Toolkit. So everything will be linked in the description or in the cards in the top right corner of the video. So feel free to check them out and watch them. That way you get an idea how to implement all of that. And now let's start breaking our workflow and explaining the idea behind it. So for that, we'll go to Miro real quick. Don't judge my drawing, by the way. I really suck at it, so just bear with me. We'll start by explaining what we are going to do. So it will start with the user provided information about the product. So a product details, product image, instructions, choose the voiceover voice or model, female voice, male voice, or whatever. and choose the gender of the character. So these ones have to be matching. If the voice you chose is for a female, you have to choose the character as a female as well, just to make it make sense. After that, we are going to take the product image as well as the product description, and we are going to provide it to an LLM, which is going to generate for us the content for the scenes that are going to be later on transformed into videos. So for the image and the product description, we are going to generate, for our case and for this video, of course, it is fully customizable. You can change the prompts however you want, but for the sake of the simplicity, we decided to go with only 2 scenes. So the LLM is going to generate 2 scenes for us. So let's say this. It is an array, as you can see, so 2 objects. This is an object, by the way, don't mind my drawing. This is another object. So for each scene, we are going to provide an image prompt and a video prompt, as well as an image prompt for this and a video prompt. And outside of that, it is going to generate for us a dialogue that our TTS model is going to speak out loud. So this one will be the dialogue here. So we'll have an array of objects containing a number of scenes that we have. Each scene will have a image prompt and a video prompt, image prompt and a video prompt, as well as a dialogue across all of the scenes. After that, what we are going to do is we are going to take scene by scene. So for our case, we are going to separate the scenes. So let's say we have multiple scenes, like we have 3 scenes here. We are going to separate them. We are going to take only the primary scene at first. We are going to pass it to Fal AI using Nano Banana and generate the image for that scene. Provide a Nano Banana with a product image that we have imported inside our form. Since we are, for example, going to advertise a chocolate bar or whatever, we are going to provide the image of the chocolate bar and then provide it to Nano Banana, which will take it as a reference and create a character holding that exact same chocolate bar. So it will be a chocolate bar here and a character. So this is the primary image. This is going to be generated by Nano Banana using Fal AI. After that, we are going to pass to the rest of the scenes. For our case, it will be only one other scene, but there are cases where you want a longer video, so this one can be like up to 5 scenes here. So for the rest of the scenes, we are going to take this image that was generated as a reference image. That way, the character will stay consistent across all the video, as well as the movement will be minimal. So we are going to pass this image as a reference to Nano Banana, and it will provide, let's say, using the prompt that we have generated here, with a reference image of the primary image, is going to provide the image for the next scene. So let's say the same person here holding the pack. And so on and so forth. We are going to have a list of images containing the primary image and the rest of the images here. After that, what we are going to do, we are going to contact Fal AI to get access to the AI video generator model that we are going to have, and we are going to start creating videos for the scene. Each video will have 1 image as a start image and 1 image as an end image. Of course, only the last scene will not have an end image, so it will have only a start image. So let's say for this one, we have 2 scenes. So the first scene will have the primary image as a start image and the secondary image that we have generated here as an end image. The second scene, however, is going to contain only the second image that we generated as a first image or a starting image, and it will not have an end image. So yeah, after this one is going to be a video, and this one is going to be a video as well. Alright, once we are finished with that, we will have 2 videos. So the idea behind this is to concatenate these 2 videos. So we are going to use the NCA Toolkit for this, using the concatenate endpoint. And we are going to provide these 2 videos, and it will generate a final video. It will have the UGC-style video generated, but still with no voiceover. On the other hand, or in parallel here, we are going to generate the voiceover using Kokoro. So Kokoro is going to take the dialogue text that we have generated at the beginning using the basic LLM chain, and we are going to generate the voiceover here. So it will be like the voice. Let's say this is a voice that was generated. After that, we are going to take the voice and the final concatenated video, combine them together, and pass them to Fal AI using the lip syncing model, and it will do the job of providing a final video that has the audio and the video that we have generated. So this one will be our UGC style ad. This is the global overview of the workflow. Now we'll go a bit technical inside N8N. We'll get back to this as a reference later on. Keep in mind, everything in here is of course customizable, from prompts or logic or models that were used. We have focused on making it as low cost as possible. So you can, if you have a lot of money, you can of course spend it on, instead of doing all of these shenanigans here, lip syncing, generating voiceover, you can just use VO3, provide it the dialogue, and it will generate a video using that dialogue without voiceover or whatever. It will have audio from the beginning. Well, let's go back now. So we are starting with a request creative or on form submission node. So to add it, just right click on add node, look for on form or form here, N8N form, and then go to triggers. Select the on new N8N from event. In this one, we are going to be capturing some information that we'll need. As I said, we are going to capture the product description, as I said here, the product image as a file, the instructions, if we need additional instructions on top of the prompt that we already have. We are going to select the voice. Kokoro provides us with a list of voices that I had to go and manually add them inside the drop-down menu in the form submission. So I went one by one and added all the voices here. We are going to need a type. So as I told you, this is part of a bigger project. So we are starting with like a field. That way we can route to whatever direction we want. We have UGC Ad. We are going to include a product tag containing the product photography, the product name, a cool name that sells, a cool description that sells, copies for the ads, etc. We are going to provide static ads as well. So keep an eye on the channel. They will be up in the coming video. We are going to choose the gender that must go with a voice that we have chose. So if we chose a female voice here, we'll have to choose the character as a female and vice versa. So yeah, this first node, of course, can be changed to a Google Sheets node or any other node, webhook, for example, or whatever. We are going to use a route or a switch node for the rest of the workflow. That way we know which feature of the system we are going to use. So since we are starting only with the UGC, so we only have one finished here. So we are going to start with the UGC. After that, we are going to need or use a basic LLM chain, which will be the brain for our content generation here. So right click on add node, look for basic LLM chain and add it. For the basic LLM chain, we are going to need some configurations. So change the source for prompt to define below here. After that, we are going to provide a user message or the prompt. That way we give the LLM a bit of instructions on what it is going to really do. So for our case, we told it that it is going to generate 2 scenes. You can change this to 3 for how long you want the video to be. So that depends on this one. We gave the inputs, we gave the product details, additional information, and the gender of the character. That way it will generate based on that. This, we told it that it has to generate a dialogue. It has to generate scenes that must be coherent, etc. We gave it some instructions there, gave it a few shot example. That way it knows how to output the data. Now we are going to hook it to an LLM, which will be the brain for this basic LLM chain. So for our case, or if you want to add your basic LLM chain, just go here. Let's start from scratch, for example, just to show you how to choose. So it will be a model here. Just click on that model. You will have a list of LLM providers here. So I chose Google Gemini chat model that because I'm going to use Gemini 2.5 Flash because it's free and we are trying to lower the cost. You can change the model by choosing any other model you want, like OpenAI, and choose GPT-5 if you had money to spend and want better quality. But for our case, we kept it simple. We went with Gemini 2.5 Flash. It will be like this. You will have to choose the model from this list here and provide your credential that you get from the Google AI Studio. Just click on create new credential and provide the API key that you got here. After that, you will have to activate the required specific output format. As I showed you here, we are going to get as an output a JSON object that contains an array of objects, which will contain the scenes and the dialogue as a field here. That's why we are going to turn on the specific output format. Once you do that, you will have another option to include, which is the output parser. So if you go back, right click on add node, and look for a basic LLM chain again. If we turn this on, as you can see, it will give us an output parser. It will have 3 options that we can choose from. We are going to choose the structured output parser. After that, you will have to change the schema type to define using JSON schema, and you will have to copy this one. As I mentioned that we have specified, we need an object, a JSON object that contains a field called dialogue with a type of text, and scenes, which is an array of objects that contains a primary prompt, which is the image prompt, and a video prompt, which will contain the video for the scene. And we have to put all of them required. You can find this in the free community assets that we are going to provide, link in the description. You can copy and paste if you want to do it on your own. So yeah, after that, we are going to click on add prompt, select the type, name, or ID to user, Message type will have to be image binary, and we are going to provide the image data field name that we have captured in the form submission, which is a product image. That way we are going to pass the LLM the product image that to give it an idea about the project that it's dealing with, other than the description. Keep the image details to auto. How to know the name you will have to put here? It's simple. If you go back to the on-form submission here, we'll find that we have named the image field to product image. Just copy the name there, put it here as a product image, and replace any space you have with underscore, and you will be set to go. All right, after we have got our object generated using the LLM or the content for the video generated, we are going to split, as I said here, these scenes. We have the primary scene that we're gonna use as a reference in the rest of the scenes, so we are going to separate them, keeping the first scene on its own and the rest on its own. For our case, we have only one rest, so we are going to use this code node here. To include a code node, click on add node and look for code, and just include it here. And then you will have to switch the mode, run once for all items. The language, keep it JavaScript, and then you will have to copy this from the assets that we'll provide in the link in the description. This one is going to take the scenes object that was generated with the LLM. We are going to take the first as its own, as the first object in the array. And then we are going to take the rest and return it as a JSON object, first and rest, both on their own, so we can be able to map them separately in the rest of our workflow. Now we are going to pass to the main block, or one of the main blocks. So we have generate primary image, generate rest images. As I mentioned in the Miro board, we are going to generate the videos, generate the voiceover, concatenate the videos, do the lip syncing, and then download the output video. So for this, we are starting with another code node, which is going to just reload the image. So basically, we are going to reload the input from the form submission because it got lost here, and we are going to need it directly, so we'll be able to map it directly. So it is a simple line of code here, just copy it as it is. After that, we are going to take the image, since we have uploaded it in the form submission, and transform it into base 64. For this, we are going to need the node transform to base 64. So click on add node and look for extract from file. After that, move file to base 64 string. And this, you will need to configure it. So again, the same field name, product underscore image, since we have a space between product and image. The destination output field, keep it to data. And then we are set to go with this node. After that, we are going to use a set or edit field node. So click on add node, look for edit field, include it here. And then we are going to map to variables from this. So we are going to take the base 64 string that we have generated in the previous node. So as you can see here, we have data as the output field here. And here we have it JSON.data. So it will be in the input schema here. Just drag it and drop it from the previous node. For the MIME type, we are going to take the MIME type of the image from the on-form submission node. So it will be the on-form submission here. Just drag and drop the MIME type of the product image there. Or you can just copy it as it is. That way we have two variables now. One called base 64 and one called MIME. This one has the base 64 string and this has the MIME type. We are now going to start communicating with Fal AI and communicating with the AI models that we're using, starting with the first model, which is the image generator model, Nano Banana. As we mentioned here, you can look for any model you want. We went with Nano Banana, the image to image, not text to image. So we are starting with the image to image. If you want to know how to use it directly, it's repeatable workflow that we're gonna use in any Fal AI communication. As you can see, starting with the initiate and the call, then waiting for it, getting the status, and based on that status, either we are going to wait if it's not completed yet. If it is completed, we are going to download the image or the output that we have got from Fal AI. So if we go back here, if we go to API here, we can choose what language we want, since we are using HTTP request. So click on this. It will give you all the needed information for your HTTP request call. We have already done that, so we're starting with the HTTP request. Right click, click on add node and look for HTTP request. The method has to be post. For the URL, it will be always this part as a beginning, Fal AI, and then after that you will have to include the name of your endpoint that you're going to use. For our case, we are going to use the nano banana slash edit, so you have to copy it as it is. For the authentication, we'll have to create an authentication once and for all. That way we can reuse it in the other calls to Fal AI or whatever we call Fal AI. So authentication, select the generic credential type. For the generic auth type, select header auth. And then you will have to create your header auth. So click on create new credential here. The name has to be authorization. If we go back here, we'll find that we need authorization in the header and then the API key. So for this, we'll have to include, let's say, key here, and then copy and paste the API key that we got from Fal AI. You know how to get your API key. Just click on the top right corner, select account. After account, go to API keys and create your new API key and just paste it in here. I have already done that, so we'll not need to redo it again. Activate the send body. For the JSON, body content type, select JSON. Specify body using JSON, and then for the JSON body itself, you will have to copy and paste from the asset that we have in our free community, or you can pause the video and copy it here. So we are going to pass in the prompt that we have generated using the LLM chain. So we are going to take only the first, the primary prompt, by the way. So using the split code node that we have split the first image from the rest. So we are going to take the first image prompt, and then we are going to pass in the reference images as a URL. So image URLs, 2 points here, an array, so we can pass in multiple reference images. We have chosen to pass in only one since we are going to take only one product image. So this one will be, as you remember, we have created two variables, one containing the MIME type of the uploaded image and the form submission, and one containing the base64 string that we have created. So all of this is taken from this previous node here, so base64 and MIME. It will have to be like this. So json.mime, data 2 points, json.mime, base64, and then pass in the base64 here. Alright, like this, with this HTTP request, we have initiated the call. Now we are going to include the wait node. So right click on add node, look for wait. After that, we are going to specify the wait amount, so it will be 5 seconds. After time interval, of course, wait units to seconds. After that, we are going to initiate another HTTP request call to the URL that we got as an output from this first HTTP request here. So if you open it there, the method will be get for this time. The output of the previous node or previous HTTP request, we have to drag it and drop it. We'll use the same authentication that we have created for Fal AI. This one will not need any body, and set the timeout with 10,000 seconds. That way we give it a bit of time to get the status. This one will gather the status for us, so its output will be sent to a switch node, which has 3 cases. Either it's completed, in progress, or in queue. If it is completed, of course, we are going to pass directly to get primary image, which is another HTTP request containing the get as a method. The same URL that we got from the first HTTP request output, the same authentication here, and without any body. This one is just going to provide us with a link to the image that we can use later on. If the call is not, or the status is not completed, so it's in progress or in queue, we are going to go back to the wait node here. Assuming that we got our first image link, so we are going to pass in directly to the generation of the rest of the images. So again, an edit fields node. For this, we are going to create 2 variables. So for this one, we are going to take the rest of the images or the array that we have separated in the code node here. Again, we got the primary image on its own, as I mentioned here, the primary image, and then we have the primary image and then the rest of the images. So we are going to take the output of that code node and take only the array that contains the rest of the images. For our case, it will be only one image here because we have 2 scenes. In your case, it can be multiple. We are going to provide the image or the URL of the output of the image generation for the primary image. This one here, we are going to provide it as the primary image field here. After that, we are going to map through all of the rest of the images, prompts, or the object or the array that we generated. For our case, it will be only one item here. Multiple cases, it can be more than one item. So we are going to split that array we got. So this array here, rest, we are going to split it out into multiple items. And then we are going to iterate over all the items using the loop over item node. So right click on add node, look for loop, and get the loop over items here. After that, we are going to pretty much repeat the whole process we did for the primary image for the rest of the images. So starting with initiating the image creation request, waiting for it, and then getting the status. Based on the status, we are going to route it, complete it. We are going to take the URL of that image. If it's not completed, we are going to go back to the wait. The only thing that has changed here is pretty much the reference image. So this time we are not going to take a base64 string, since we don't have the image uploaded to our N8N workflow, unlike the product image that we have uploaded. So for this one, we have already an URL, and this body request takes a URL. So we are gonna map it directly from the edit fields here, this one, that we have set already the primary image. So we are going to take the URL directly and pass it as a reference image. That way all the rest of the images will contain the same image that we have. And it will be pretty similar and consistent. That way we don't mess up the video later on. So after that, we'll loop over all of the images that we have in REST. And then once it's done, we are going to aggregate all the URLs that we got from that loop here. So it will contain the URLs of the output images for the rest of the image. So if we have 3 REST images, we are going to take 3 URLs, each containing 1 image. After that, we are going to create a code node. What this code node will do is it will prepare the scenes, create the object for the scene. So as I mentioned here, each scene will have a start image and end image. So we are going to need a code node that will take the prompts that we have. So the video prompts that we generated from the basic LLM chain. And we are going to take the image URLs that we have. It will create a loop. Basically, it's going to map them here and then create a loop. And for each prompt, video prompt that's contained in a scene, we are going to include the start image or an end image. If the end image doesn't exist, it will be undefined. So this is what this code node does. You can get it from our community, or you can pause the video and copy the content of it. So yeah, once we have prepared the scenes, of course, we have multiple scenes. We have 2 scenes, 3 scenes, or whatever. We are going to iterate over them. This one is going to provide a list of items. We are going to iterate over the items to start generating the video. The logic is pretty much the same. It is initiating the call, waiting for it, getting the status, and then downloading the video or getting the URL of the output video. So for this, pretty much the same. So since we are going to use a Cdance V1 Lite image to video model, so if we go to Fal AI here, look for Cdance, this one here. So we'll have to copy ByteDance Cdance V1 Lite image to video, copy this part, include it in the URL after the Fal AI. Of course, this part is static for everything. We are going to use the same header auth that we have created there. We are going to send a body, JSON using field below. We are going to send the prompt here that we are going to take from the item. So this is providing an array of items containing each a prompt, start image and end image. So this one, we are going to provide the prompt, the image URL, and the end image URL. It will be the output of the loop node here. So drag and drop the prompt here, the image URL here, and the end image URL. The resolution, keep it to 480p. That way we don't consume a lot of tokens. You can change it, of course. Duration, it's 8 seconds only. All of this depends on the model that you use. If you use Veo, it will be much simpler, but we have decided to go low cost and use the Cdance V1 Lite image to video model. The rest is pretty much the same. We are going to take the URL that this node outputted and put it in the get request here to get the status of the video generation, and then map it through the switch node. If it's completed, we are gonna get the output of that video. If it's not, we are gonna wait. So this one, since it is a loop node, we are going to take multiple output URLs for all the scenes. If you have 2 scenes, we are gonna take 2 output URLs or links contained in the video. So after that, we are going, if the loop is done, as you mentioned, as you can see here, so if it is done, we are going to create an aggregator node. So right click on add node, look for aggregate, include it here. Make sure to configure it like I did here. So aggregate all item data into a single list, set it here. The put output in field data, keep it like this, and include all fields. All right, now we are going to branch out into 2 branches. Here we have the first branch containing the generate voiceover and the second branch containing the concatenate video. So for the voiceover, we are going to use Kokoro. So if you watched the previous videos on how to use Kokoro to generate voiceover, you are familiar with setting it up. So next thing to do is include an HTTP request node containing the post method. The URL is always like this for Kokoro. So it will be localhost 2.8880 as a port /v1/audio/speech. For the body, it will be JSON using JSON and this body request here. So we are going to pass the model, which is Kokoro, the input, which is the dialogue that we got from the basic LLM chain here. Since we have parsed it out already in a JSON, so we'll have the field dialogue, just map it inside the double quotes here. For the voice, we have already set it inside the on-form submission, so drag it and drop it there. Response format, we needed a MP3, and the speed, keep it at a normal pace, 1. One more thing, just to not forget, if you're using N8N on Docker and not just self-hosted using CMD and PX like I did in my previous videos, you will have to change this to host.docker.internal, since N8N will be in Docker as well as Kokoro will be on Docker. N8N for me is not on Docker, so I'm gonna use localhost here. What this will do is it will provide provide a binary file here so as an output. So we are going to take that binary file, upload it to Drive. So right click on Add Node, look for Drive, Google Drive, select the Upload a File action here. You will have to set up your Google Drive account, keep the resource to file, operation upload. The data, input data field name is data. Since the output of this HTTP request is going to be in a binary field or binary file called data, you'll find the name on top, so keep it same as that name. Name the file however you want. I kept it to audio. The parent drive is my drive, and the root folder, you can select the folder that you want if you have created one inside Drive. I didn't, so I kept it to the root folder. You don't have to add any options here, so you're done. After that, we are going to make that file shareable. So we are going to add the share file action from Google Drive. Again, select the Google Drive account here, operation to share. The file, we're going to select it by ID, so the previous node, this node here is going to output an ID, so we are going to drag it and drop it inside here. That way we have the same file. We are going to set up permissions, so right click on Add Node. It will give you an option here to add permissions, so select the role to reader and the type to anyone. And then once you are done, you are going to use a edit field here. We are going to build, since this one doesn't respond with a shareable URL, we are going to create it on our own since it is a pretty static format. So it is going to start with this part here, export, download, and then ID as a parameter. We are going to add equals, and then we are going to drag and drop the ID that we got from our node here, the upload a file node. So drag it and drop it there. That way we make sure we have the file URL. Name it as a variable called audio URL that we can use later on in the lip syncing part. All right, moving on to the second branch. Keep in mind, as I mentioned before, these ones will be running in parallel, so it will generate the voiceover and concatenate the videos at the same time. We could have used here a Fal AI endpoint to concatenate the videos, but that is going to cost us some money. So we tried to make it using the NCA Toolkit to keep it at low cost. So we are preparing the video URLs using a code node here. We are going to take all of the video URLs from the previous aggregator here that we have and separate them together and concatenate all the videos into one JSON object that contains videos and contains the array of the videos here. So after that, we are going to create an edit field node, which will contain map video URLs. So we are going to take the JSON object here. As I mentioned, we are going to create a JSON field here containing the array and under a field name called video. So we are going to take the videos there, drag them and drop them under a variable called JSON. The type is string, of course. We are going to take them. After that, we are going to call the NCA Toolkit endpoint, which is the concatenate scenes endpoint. So if you open it, it is a post request using the HTTP request localhost. NCA Toolkit is under 8080, so we are going to use the v1 video concatenate. If you go to the documentation of the NCA Toolkit, we will scroll a bit down, find a video here. It will be this endpoint here, v1/video/concatenate, etc. It will give us examples of the body requests. For this, we are going to pass in just the video URLs and pass in the field that we have the video URLs there. So yeah, after this will do its job. It will respond to us with a URL that contains the output video. So we need to download it. That's why we are going to use an HTTP request with a get method. We are going to pass in the output of that concatenate endpoint. So since, as I said, NCA Toolkit is hosted on Docker, so it will respond with a link starting with host.docker.internal. We are going to need to change that to localhost. So we are using a pre-built-in function called .replace. So we're replacing this part here with localhost and keep the rest as it is. We are going to add one option here, which is going to, it is removed from here, but it is response as an option. Once you include it, keep this as it is. For the response format, we'll change it to file instead of text. And the output field, we'll put it in a field called data. That way we know where to use it. So we are going to upload it again to our drive. We are going to take the input data field name to data, give it a name video. The previous was audio, this one is video. Keep it to the root folder, and then we are going to share it, same logic that we did before. Get the ID from the previous node and map it here. That way we are going to give permission to anyone as a reader, and then we are going to create the shareable link using the same structure here, this one, and then we are going to take the ID that we have got from this node here and drag it and drop it. After that, we are going to take both of the outputs here and we are going to create a merge node. What this one will do is merge all the outputs, so it's no longer in parallel, so it will be sequential. Click on Add Node, look for merge, choose merge here. It will have multiple configurations, so the mode has to be combined. the position, the combined by will have to be position, and the number of inputs. Since we have 2 branches here, we are going to go with 2 inputs. Once we are done with that, we are going to go back to the same pull structures to Fal AI, since we are using the lip sync model. So it is the same structure, initiating the call, waiting, getting the status, and then getting the file once it's done. So the call will be same start of a link, and then we are going to use the latent sync. So if we go here, look for latent sync, it will be a video to video here. It will give you the URL. It will be latent sync here. So we have to choose it. Same header auth again. For the body, we are going to use JSON, using fields below, not using JSON, since it's pretty simple. We are going to need the video URL that we got from the concatenated video and edit fields here, as well as the audio URL of the voiceover that we got from Kokoro. So we are going to map both of them here under video URL and audio URL. Get the status again from the URL that was outputted by this node. Drag and drop it there. Keep the timeout to 10,000, same header auth, the wait to 5 seconds again. We are going to use the same switch node to check if it's completed, in progress, or in queue. If it is completed, of course, we are going to get the shareable URL to the final output of the video. And then after that, we are going to take the output video and download it. So we are going to use an HTTP request with a get method, as well as the URL. We are going to drag and drop the output of this get lip sync output and put it here. After that, we don't need an authentication for this. So this one will provide us with an output binary field that we can click download, and it will download for us. So this is the whole workflow done. Of course, this is the first part of the workflow. We are working on a bigger system. We are going to make this even better, provide them better prompts, maybe using different models and trying that out. As I mentioned, you can get this part of the workflow and the next parts by joining our membership, or you can buy the JSON file on its own from our shop, of course, or you can do it on your own using the assets that we are going to provide in our free community, as well as watching the video and following step by step. Just a quick reminder, we are going to create a Discord server as well, which will be free to access. It will serve for now the same as the free community. We are going to provide more assets in there. That way it will be more interactive, and you can get a hold of us easily whenever you want to send us a question or whatever. It will be more interactive to keep things easier for you and for us. So yeah, now we have finished building the workflow. Let's try to test it out. So all we have to do is just click on execute workflow. It will start the form that we are going to use. So we are going to provide a product description. Already generated this using ChatGPT. We are going to provide the product image, which is this one here that we have generated as well. We are going to give instructions, keep it to nothing for now. The voice, we are going to choose a voice. Let's say we are going to go with Jessica. The type, UGC Ad. We are going to provide the gender to female, since the voice is Jessica, so it's a female. And now we are going to wait for it. All right, as you can see now, our workflow has finished executing, so it's time to see the end video. Don't blame the quality too much for this, since we are using only 2 scenes and we're using a low-cost video generator model, so the quality might not be too good, but it will do the job. Of course, you can change the model if you have a bit more money to spend, or if you're serious about it, like to get better results. So now let's go here. Let's click on download and let's watch the video together.
Okay, so I just discovered this Choco Lux bar, and wow, it's literally the silkiest milk chocolate, my new go-to for a little luxury.
So as you can see, yeah, it pretty much did the same product image, didn't change anything in it. The quality is a bit too bad because it's 480p, by the way, so don't blame that too much. The lip syncing could be good, maybe using a different model, but this one is pretty damn good actually, if you ask me. But you can imagine this combined with VO3 and not the low-cost model, but it is pretty good actually. This has been it for this first part of this bigger system that we are creating. I hope you guys enjoyed and found this useful. If you did, please leave a like and subscribe to the channel. We are back on the grind. We are going to release at least 2 videos each week now with quality workflows, so keep an eye out on that. And shout out to Jan for being our first member of the membership plan that we have. And yeah, we'll see you in the next video. Goodbye.